give everybody here tonight is I want to give you the resources for learning how to build web apps with Go. And it's a new language, and there isn't a lot of code base out there. There's not a lot of books out there, and a lot of great resources. And so I had the opportunity to teach web programming with Go this last semester at Fresno State to graduate and upper division undergraduate students. And that was really awesome, but it was also super challenging because we didn't have a textbook. There was no textbook for the course. And so I had to cobble together the best resources I could find and put together the best material I could. And so that's what I want to share with you all tonight. The main things we're going to do is I'm going to show you, first of all, the resources for learning Go and how to build web apps with Go, so you have those resources. And I'm going to walk through and show you some of the code. So that's the very first thing. Why learn Go? So you guys all read this, and gals all read this before you came. But I'm just putting it on the screen here just in case, for people who are watching this video for the first time, because I'm going to post this on YouTube, just because that's one of the ways I was learning Go, is watching the different videos that are out there. And it was always a real pleasure when I found a video that was to the point and awesome. One of the strongest arguments for me about Go is that it was created by, let me see right here, the Go programming language began as an internal Google project in 2007. The original design was by Robert, I don't know how to say his name, Gressimer, and Unix luminaries Rob Pike and Ken Thompson. And so those people, are really, to me, heavyweights in computer science. And the fact that they created a new language, makes me take note of it. And the benefits of Go is that Go is designed to take advantage of multiple cores. So a lot of languages weren't built, today to take advantage of multiple cores. And to take advantage of multiple cores, it takes a lot of extra work. And Go is also built to run concurrency very easily and very natively, right? So being a concurrent language, runs concurrency easily. That's built right into the language. And it takes advantage of multiple cores. It means it's going to be a really fast language. And it's also built to run in distributed network environments. So multiple cores, whether it's one machine with 4 cores, or 16 machines, each with 4 cores, all in the same room, or 16,000 machines, each with however many cores distributed all across the planet, that's kind of the design and intent of Go. So it's fast. It's really fast. And one other anecdote which I found interesting about Go is I was reading this article, Structuring Applications in Go. And so, I was like, all right, who's the guy who wrote this article? And I clicked on, all right, let me read about the guy who wrote it. It's this guy, Ben Johnson. But down here at the bottom of his profile, there's this link, Farewell to Node.js by TJ Hollywaychuk. I don't know how to say that name either. I was like, what's that about? So I clicked first to see who is TJ Hollywaychuk. Whoops, sorry. Come back. Come back. Come back. There we go. Programmer, artist, creator of Luna programming language. Huh, interesting. Koa, Express, Stylus, Cluster, Mocha, Jade, Node Canvas, Component, and many others. Wait, he created all of that? Right? And it turns out he's also one of the primary creators of Node.js. And a year ago, he said, you know what, I've had enough of Node, I'm switching to Go. And so one of the primary creators of Node is like, you know what, Node's okay, but I'm moving over to Go. So to me, that was like also a really sort of, hey, let me take note of what is this new language. So a lot of real strong arguments for me in terms of learning and wanting and being interested in Go. So the resources to help you out. If you go to my GitHub account, goes to 11, there is this repo right here, Go Web App. And this Go Web App has a bunch of different branches. And as you go through these branches, they're all code samples, code templates that you could use, boilerplate. You could just pull it off, put it into whatever you're building, and here's the basic framework. Here are best practices. Here's the code. This is your roadmap for learning how to build web applications with Go. You just come here and start going through these different resources, these different branches, and they're going to show you how to do everything, from building a basic server to setting the content type with HTML and CSS, to doing templating, to doing injecting data into your templates, to doing flow control within the templates. But we'll look at some of that tonight. And those files that I'm creating mirror this training right here. So this is one of the best trainings that I found for creating web applications with Go on Pluralsight, and it just came out 2 or 3 weeks ago, April 20th, 2015. But a really great training if this is something that interests you. So the next thing I'll point out is there's also another really good training if you go to Pluralsight and just search for golang. So the language is often referred to as golang. There's also one for learning the syntax of Go and how does Go work. And that's by John Sonmez, the Go programming language. And as I went through that one, there's another repo here, goes to 11 CSUF. And as you click through Spring 15, you then come into this directory. And the one here is that corresponds to John's training, the Go programming language, is right here, O1 samples. And I have a README text at the beginning of each of these files, so it'll tell you, well, I'm not connected, so it'll tell you, hey, this is from this training. You could go watch this training, and then here's all the code that you would, that I put together going through the training. And so, I mean, whatever it is you want to learn about, the different data structures or flow control or pointers and how do they do pointers in Go. So this is a great resource, for me, and try to name everything so I can look back to it, kind of like an index, and say, oh yeah, what's the syntax on that? How do I put that together? And have that right at hand. So that's that. And then there's also a really nice book, An Introduction to Programming in Go by Caleb Doxey. This is actually the guy who's going to come and be our trainer for 4 weeks here this summer. And I hired him because I liked his book so much. But here's the code at same place, but under this folder on GitHub from going through that book, so you could take a look at that. So to me, that's some of the most important things that you could take away from tonight. I will mention one other thing just right at the beginning, is that when you have learned how to create web apps with Go and you've learned the syntax of the language, at some point you might be like, okay, I could build this all from scratch if I want to, or I could go get code that other people have written. And so there's a lot of different libraries that are out there. Like I think there's like maybe 10 to 20 different routers people have written. Routers of more complexity. So I'm going to show you how to do basic routing tonight. And the best router that's out there is Julian Schmidt router. And so you could just GitHub that, Julian Schmidt router GitHub. And why do I say it's the best? It's the most performant, and it's also has sort of the best, I don't know, he uses trees to just sort of do his structure for looking things up, and that's really fast. And he's also ranked did benchmark performance testing against all the other routers, so you can see where his falls in relation to all the other ones. And so I was just impressed with that, but make sure you put that on your radar if you are doing it. One more thing, which I think is cool, I've been using WebStorm. So WebStorm is put together by JetBrains, who does Android Studio in conjunction with Google and IntelliJ and PHP Storm and different IDEs. And so if you're watching this video and you're new or to web programming or just learning this stuff, you might check out this training on WebStorm fundamentals too. WebStorm is real nice. All right, so before I get into sort of showing y'all some code, does anybody have any comments or questions? And we could just generally talk about what I've gone over so far. I don't know if you have any questions or thoughts about the language. So if you do, just jump in at any point. Let's make it interactive, and I'll show you guys some stuff. And I know that up here, you don't see my comments very well. I don't know, could somebody maybe hit the lights and see if that helps? But the first thing I'll show you is here I'm in WebStorm. And WebStorm will serve a file. And so here's a basic HTML, CSS, a little bit of JavaScript file that I put together. And there's no server-side logic running on this. It's completely static. But I'm going to start with this, and it's just HTML, CSS, JavaScript. And now I'm going to start to integrate Go into serving this page. And so that first thing you saw there is serving through WebStorm. And I have a few notes here just on this first iteration. But the convention in Ruby is convention over configuration. That's like the saying for Ruby, convention over configuration. And for Go, I think it's configuration, 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 sometimes conflagration, sometimes consternation, right? But Go really gives you as much flexibility as you want, right? They say, here are all the tools, do whatever you want with it. And so it's not really the super easy language where you just, it's not the super easy way to build web apps where it's like, grab this, stick them together, and there it's running, right? It's like you need to know what you're doing. And if you're willing to pay those dues, you're going to be able to build something that's awesome. And by awesome, I mean it's performant. So let me just mention this too. Like if you build your web apps with Go, and then you host them on App Engine, right? And you use Google Cloud for your data storage, you're going to have as performant of a website as you could possibly have. You're building your website with the same architecture that Google uses. And it's also going to easily scale. So you're no longer going to have scalability problems. So I don't know if you've looked into App Engine at all, but App Engine, Google Cloud for data storage, and golang, to me, is the absolute best solution you could choose for building web apps today. And the second choice for me would be Node.js because it's Go is twice as fast as Node, and then behind Node I would choose Python, and then behind that I would choose Ruby, right? And Go is about 864 times faster than PHP from some of the metrics I've seen, so it's kind of nuts. But the first thing that we're going to do is we're going to create a resource server, and so the server is just going to serve some resource. And to do that, we need it to listen on a TCP port, and we also need it to handle requests and route a URL to a file. So the old school way of building web pages was like PHP, ASP, whatever, right? Your URLs actually mapped to some file in a directory structure on the server. And the new way to build web apps, and I've been reading about RESTful architecture, refers to this too, is to have your URLs just basically be calls to methods and functions. And so when this URL comes in, your server sees that and says, oh, you're calling this, right? And so it doesn't map to a page anymore. You might have a page where many different functions on it, and depending upon the URL, different functions fire. And so the resource server needs to listen on a TCP port and also handle requests. So it'll route a URL to a file or to a function. And so in Go, there is one term of confusion is sometimes they refer to a server as a servmux. Sometimes they refer to it as HTTP request router, and sometimes they refer to it as a multiplexer. And I know it's a little faded out here, but you can see all of those terms are equal: servmux, HTTP request router, or multiplexer. And there's a link there to a good article that talks about that. And then sometimes in the documentation you'll hear about mutexes, right? And a mutex is, that's better. A mutex is mutually exclusive, right? So that's more for concurrency and blocking and things like that. So don't confuse mutexes with multiplexers or servmuxes or request routers. So servmux is a request router, is a multiplexer, is also a mux, M-U-X, right? So those are just some of the terminologies there. It's just a router. So it's routing URLs to do something. So let me switch here to the next branch. And it's going to tell me probably that, because I haven't figured out, it's actually a weird anomaly I can't quite figure out. But, yeah. WebStorm has a file for its own implementation. It's the IDEA folder. You can see that right here. And I haven't figured out how to get Git to ignore that yet. I've tried. Git commit. There we go. What's that? Okay, you show me afterwards. I'm glad you're here. All right, so I just switched, and if I do my Git branch, I can see I'm now on the second version. And this right here is going to correspond to this one right here, which I'm not going to switch to because I don't have Wi-Fi right now. So that will correspond to that code. And we are ready to come back here, and it'll say, hey, you changed your project. And you can see I got a lot more comments dropped in there. And now I've got some code here. And so we'll just look at the code here for a second. I'm going to give you a minute to digest that. Just look at it and make sense of it yourself, and then I'll tell you some notes. So pretty straightforward for running a server, right? Like main package, you have different packages to organize your code. And then I'm importing, a library package, the net HTTP package. And then my main function, which is where everything starts. And, I'm just in the HTTP library, there's the handle func. And I'll talk a little bit about it in a second. It's basically saying anything that comes in at the /, and it's the routing in Go is whatever's the most specific. So that's what gets called. So if I put /John, well, is the most specific to that. So / would actually serve at /John. But if I had another chunk of code here like this, then when I went to John would serve some other func. Right, but if I put in there, Sally, then this would fire because this is the closest match to Sally, right? So that's just kind of an interesting thing about it. And then the listen and serve says listen on localhost port 8080 or port 8080 of wherever I put my server, and nil here means that we're going to use something. We're going to use the default serve mux, and then here's my sum func. And it takes a writer, so it's going to write my request back to the whoever asked for it, and this is the incoming request. So there's all kinds of variables and things that we could reference off a request, and you're going to see me do that in a second. So we have an incoming request, and then I'm going to for the write response, the response writer, I'm going to write a slice of bytes, which is basically each letter is a byte. So a slice of bytes, hello universe, I'm going to write that back. And so we'll just see that in action, and we'll come back here and we'll take a look at the notes. First I got to fire up the server. And so I'm going to point out two things here. First thing, if we look at my working directory, I'm in Go Web App. And so right here, there I am in Go Web App. And so this is super critically important. If you are watching this, you really want to make a note right now, but wherever you are in your directory structure, when you say, hey, I want to now run main, right? Wherever you are, that becomes your root for your server. And so if I ran main, if I change directory down to source and then main, right? And now I'm in there and I list and I say, hey, okay, there's main, and I go run main go, right? Okay, cool, it's running. And then I come here and I say, all right, let's check it out. Localhost 8080. Whoa, it served. Because all of my code is actually only right there. But we're going to see this not work in a second. And actually, the right way to run it would be to be in the root of, to call it from the root of my application. So right now I'm in Go Web App, and if I do Go run, and then I have to type in source and main, and then main.go, and this will also run. So just refreshing on that, and it ran 2 from there. But later, as I try to call files, like in this folder or whatever, if I'm in this folder when I run it, it won't run, but I have to be in that folder when I run it, and it will run. You'll see that in a second. It'll make sense. One more thing I will point out, just for whoever's, But when you create your Go applications, you really have to have a specific folder structure. So you could call it whatever you want. And so there's Go. I could have called it my folder, whatever. And inside that, I've bin package and source. And so that's just a Go convention that really streamlines grabbing packages. And so you could get packages, and it's kind of like npm. It just brings it down and installs it. And then inside bin package and source, you need those 3 folders. It's good to have a naming convention where you have github.com and goes to 11, because that just provides a unique namespace. And then anything in here, I know these are all my packages, so as I push them up to GitHub, they correspond to mine. But I pull down some other guy's package, and it throws it in there under his folder. So that's just one thing you really need to know when you're getting started with Go, and that's pretty clear when you get started. They explain that. And then the other thing, which is super good to know, is is that you need to have certain path environment variables. Get I thought it was get env. No, I'm looking for go env. Sorry. All right, so there we go. Oh, there, I'm pushing the wrong one. So you have a Go root, which is set to wherever you put your folder with all that you download. Like, hey, I want to get going with Go, and so you download. You go to install Go, and you get the folder, and then it gets installed somewhere, and you can say where you want it to be installed. And so wherever you install that's what you need to set your Go root to, and this should automatically get set. Usually on Windows, it's just straight into your C drive, but you know, on a Mac, you could see it here in a second. All right, so there it is on the Mac, right? I'm just straight in user, local, and then that folder Go, and this is where like all the code is for, you know, Go, the programming language. And so I would never write code or put anything in there. I want to keep that separate. And then the other one, the Go path, these point to your workspaces. And so I've seen a couple of different perspectives on, some people say, hey, only one workspace. And my favorite perspective is I want to have a workspace called GoLib or whatever, and that's where it's going to store all my libraries as I like download code from other people and install it. And then what happens is there's a command called go get. And so as I say, hey, go get this, go get Julian Schmidt router, and I put in his GitHub account, and all the documentation for Go is there. When you start looking for other people's code, it says, oh, you want this, then go get, and it's just github.com Julian Schmidt HTTP router. And so it would install it in that location. It goes to the first location in your Go path. And then these are just other workspaces that I've set up for my own stuff. So that's the one I have for my own stuff right there. So I'm keeping my code from other people separate from my own code. And that's how I do that. So that's good to know. All right, so we were talking about creating a little bit of a server. And I'm just looking here at the notes. One other thing which is really nice to know is this bit about raw git. I don't know if you know that, but check it out. That's more like web development. And if you want to serve a file straight from GitHub, it's more like for testing and sharing with people just before you go live. You could do that. Another really nice thing to point out, now we're talking about serving files, is that App Engine, you can pretty much host and serve your website for free unless you get enormous amounts of traffic. So Google's App Engine, which will support Python, PHP, Go, or Java, right? One of those four languages, and that's a platform as a service as opposed to infrastructure as a service. In which case, you could do whatever the hell you want if it's infrastructure as a service. But platform as a service, you could host through App Engine. I've got a couple of sites running right now, like summerwebbootcamp.com. That's all, like I don't have to pay for hosting. I just put it up there and it's on Google's CDN, Content Delivery Network. It's on Google's CDN, and it's super lightning fast and it costs me nothing until I get thousands and thousands of page views a day. So here's a little documentation about listen and serve and HTTP handle and HTTP handle func. But the idea here is basically there's a handle and a handler, and handle func maps to a handler func. And you can look through this on your own, just out of interest of time. And then here's also some resources. Not to mention you could download this code. I think it's fun just to see the code run. So let's switch to the next one. So I don't know what the heck's running here. And I want to do a get add-all and get commit-m and because of that, and get branch and get checkout. 03 muxes and then get branch just to make sure that actually happened, and then switch, and let's look at the new code and see what's different. What's different?
Put new text on it?
Yeah, I added my my own mux on it. So before I was using the default mux, which meant nil, right? But here I've created my own mux. And what does mux stand for? Multiplexer. What's another thing you could call multiplexer?
Router.
Yeah, HTTP request router, and there's still one more word that it gets referred to as?
Server.
a server. Sure, I can't remember all of them. I think I have them up here. I don't, but whatever. They were on that first one. So I just created my own mux. My mux equals new serve mux, and my mux handle func, and same thing, and listen and serve. And so it's the same deal, right? But this time I'm using my own mux instead of the default mux. And so it gives you some flexibility. Here we go, serve mux, request router, multiplexer mux, right? And that compares the incoming request against a list of predefined URLs and calls associated handler for the path whenever a match is found. And handlers are responsible for writing the response headers and bodies, right? And so my handler here would be right there, some func, and responsible for writing the response headers and bodies. Almost any type object can be a handler so long as it satisfies the handler interface. In lay terms, that simply means it must have a serve HTTP method with the following signature. Right, so that's that. Like I said, you could read this, but let's just watch it in action. And fire away if you have questions. So here, print working directory, and then I can just scroll through this. There we go. And it should be running. And hello, Los Angeles. Super exciting. Let's switch to the next one. Control C.
Why would you use one over the other? Why would you use a mux as opposed to
the default serve mux?
Yeah.
So if you start getting really into complexity and wanting to customize. Otherwise, if it's just simple, just use the default one. But if you want to start to adjust properties and things like that, you use your own. And I haven't quite gotten there yet myself. So
is it kind of like changing the what is it, like the route name in say MVC? Is that kind of what it is? Just specifying like a collection of routes or route packages, or no?
The mux?
Yeah.
Let's take a look at it. Hold on. And then when we have one up, I want to hear your question. All right, so ask me your question again, and then maybe I could reference the code.
Figure out like are you familiar with MVC? You can specify like a default route, and then an alternative route, and then you can have a kind of like a list of routes. So I'm wondering, is that what that is then? Basically, the equivalent to?
Yes.
It is.
Yeah.
Okay.
And so all of the equivalent, I would say, is all of this, right? All of this, because for all this to happen, we're specifying routes and we're saying what to do with that, right? And when you specify the routes, you can not only specify the URL, but you could also specify incoming header information. Mm-hmm. So you could say, you know what, it has to be get, or it has to be post, or whatever, and depending upon which it is, you'll do different things, right? So here's an interesting situation. Just take a look at this code for a moment. And the commented out stuff is what I had before. So before I had, I'm going to create a new mux. And then my mux, I'm going to say, hey, handle this, right? And so anything at this route, serve this function. And then it went and called a function person1, which isn't showing here. And then I did my listen and serve 8080 and, hey, use my mux, right? For anything that's coming in at that port, use this mux. And so here what I did, what's different is person1 is created, an instance of, and interestingly, Go is not object-oriented, which is weird. But there's a lot of things about it which you could translate object-oriented principles pretty easy. So it's all based on types. And so up here, I create a new type. And this type is a struct, and it's called person. And case is important in Go. So if it's a lowercase, it means you can't access person outside of this package. Only inside this package can you access person, so that's like private. But if this was a capital P, then outside of this package, I'd be able to access person outside of it, right? So the case is what determines private and public. And so, huh?
So you're kidding me.
Yeah, cool, huh? And so I create a new type, and it's a struct, and it holds, you know, this data. And so just like objects can have data and methods, well, here's the data. And then here, I'm attaching to any person, right? Any person struct, I'm attaching this method. And so this is a function. If this wasn't here, that would be a function. That is now a function. But with that there, that becomes a method. What is it a method of? It's a method of any person struct, right? So any instance that I create of person, and I don't even know what word to use since it's not object-oriented. That's just the object-oriented word. But any instance of person that I create would have this data and this method. And this is called in Go a receiver. So person is a receiver to, serve HTTP has the receiver person. So person is receiving this method. So that's kind of just some of the terminology. And so I created that, and since person now implements the handler interface, and to implement the handler interface, you need to have the serve HTTP method right here with those parameters, those arguments, those parameters, right? You need to have that. Now that makes this a handler. And since this is now a handler, I could come in here and I could just stick the handler right there, and it will serve this. And so I create an instance. First name is Jim, and I could, I don't know, let's see what happens when I run it. So first name Jim. So like I said, configuration. Go really gives you as much power as you want and can understand to configure, you know, distributed networking applications, you know, or web apps. Yeah, so that's just kind of an interesting deal. You know, you can read the notes on that for more understanding. This is just kind of a quick tour. And let's do a git add all, git commit, whoops, git add all, git commit dash m, and git branch, and git checkout 05 serve file, git branch, just confirm it. Alright, so here's the next one. Some wild stuff going on there. Where am I? What is that? Close the wrong one. Like my directory is crazy. All right, so now we're going to start taking a look at what did I call branch 06? Branch 06 is serving a file. So all we've been seeing so far is like, hey, we're working with a request router, and when a certain route comes in a certain path, run this function, and that's all on the main page. But now, all right, well, great. How do we start serving files? And so here is the basics of it. And I'm importing a few more packages. I have the net HTTP, and then input-output utility, and then also log just for debugging, so I could like see, you know, stuff. And wow, those colors are pretty awesome up on the screen. That's pretty bright. So I just have a myHandler struct with nothing in it, and I'm attaching to that the serve HTTP, which is the, you know, the handler interface, and so that turns myHandler into, or turns myHandler into a handler since it implements the handler interface. And then, you know, func main, I always like starting with main. I'm saying, hey, handle anything at this route, and I'm creating a new myHandler. So you can imagine trying to figure all this out just by reading the documentation. How do you do it? Total pain. But great to have the code pass. So if this isn't familiar to you right off the bat, you know, don't sweat it. Just be blessed that you feel blessed that you have code samples. So I create the new myHandler. and then listen and serve 8080. I'm using the default serve mux. So it's kind of interesting just getting your head around how all that works together and the differences we just went through, but that'll take a little bit of time. So what does serve HTTP do? It says, hey, off of the request, and I named it R here. A lot of times it's REQ, sometimes it's R. Get from the URL the path and slice it from the /. So slice the / off, so it's 0 base index, like a lot of slicing, right? So that would include the / of the URL path, but this says, hey, everything but that. And then I'm going to print the path out so that we could see it. And then here we have read the file, and that is at that path. So whatever path I put in at the URL, it's going to read that file from the server and return. And this is interesting about Go. First, two things. Here's the shorthand notation for assigning a variable, and also say what are the three types. I always have to stop and think about this for a second. You have assign, you have initialize, and you have declare. And so to declare would just be like, hey, I want my num int, right? Var my num int would be declare, and then my int equals 7 would be assign, and then to initialize would be both of those things at the same time. Anyhow, this is the shorthand notation for initializing a variable, and it just infers the type, and you could only do it inside of a function. So if you're outside of a function and you try to do like my var, that won't work. You have to say var my var int, and this is also something that trips people out, is that you say the type after your variable instead of the type before. So my var is an int, as opposed to like my var int my var. A lot of other languages are like this.
It seems verbose. Is there a stated reason for that? Is it?
Well, pretty much all languages you say the type, right? But you don't have to say the type if you're inside of a function, and it'll infer the type just right here, and it's statically typed. So once you assign a type, it can't change. Though you can do casting and reassign and things like that. And you also semicolons get automatically inserted by the compiler. So this would throw an error because it'd say, hey, okay, that needs a semicolon when it compiles, right? But this, when it sees the open curly braces at the end of the line, it knows don't put a semicolon. But if it sees the parentheses, it thinks put a semicolon. And so you have to have that syntax. And then there's also you don't have to worry about coding convention, like what style should I use. There's built into the language an automatic code formatter that when you run it, and most good IDEs, and by the way, I really recommend WebStorm for your IDE for Go, and let me just point that out too. But most good IDEs will automatically format it. Like if I say, I just did Command-Shift-L, which on the Mac in WebStorm reformats my code, and it runs Go format. That's actually the I can't go on the web, so I can't show you. That's the command that gets run, Go format. And it formats it according to Go conventions.
The formatting is built into the language?
Built into the language.
That's
Yeah.
interesting.
Yeah, formatting is built into the language. Yeah. So what was I going to just say about WebStorm is when you want to work with WebStorm, you go into Preferences, and then you have Packages, and you have, let's see here, Go Libraries. I'm just looking for, I thought it was Packages. See you, Nick. I know you had to go. Plugins, that's the word I'm looking for. So you have plugins here, and you could come here and you could search for plugins. So you just search for golang and or Go, and there's also browse repositories right here, and so that'll take you out to the web, which I can't do. And when you go out to the web, you'll find the Go repository. Here's the URL for it, but get to it by going to Browse Repositories right there, and then make sure you say Show All, because it shows like 3 versions, and it doesn't show the newest versions. It shows like the most stable one, which was like a couple months ago, and you need the version from like April forward. So the one from like December isn't that great, but April forward does a lot of the stuff which before April I was frustrated with. So just make sure you get that when you set up WebStorm. All right, so we read in the path, and if there's an error, so if error is nil, so if there's no error, we're going to write, because here we got the W, response. We're going to go for our response. We're going to write the data. So whatever data we found in that file, which we read at whatever path we put in at the URL, we're going to write that back to the client. That's it. And then otherwise, we'll write a 404 error. Hey, we didn't find a file at this path. And the path is, right, whatever somebody put in at the URL. And so we'll write 404, and then we'll give them, that message, hey, 404, my friend, and then show them the status code again. So let's take a look at that. So this writes it into the header. This shows it to the body or the client. So let me show you the difference. How many people? Let me see a show of hands when I say header, body. How many people aren't like HTML web programmers for your trade? 2 hands, 3 hands. So you guys do a lot of web? Yeah, some. All right, cool. All right, so let's run this and play around with it. All right, and come over here and refresh. And 404, my friend, not found. Interesting, right? Well, what does this do again? It takes whatever's at our path and from the /forward, and then it prints the log of that. Well, let's see if it printed any log. Hey, it did. It printed a log. There's nothing there. This is where I ran it, right? But then it logged nothing, and also my fave icon. And then, right, it gets the path, and then it tries to read any file at the path, and then if there's no file there, it gives me a 404. So my path is actually templates /home.html. So let's see what happens if I type in templates /home.html, and there's my page. Ooh, awesome. And if I look at my log, look at what happened, right? So it ran these two right here the first time, and then here's the new time code, and it gave me this on my log. And in templates home HTML, that's great. And the rest of that stuff looks like it's calling correctly. Public CSS reset, right? If I look at my directory, public CSS reset. So that all looked like it called correctly, which would have called from right here in my head, right? So the question becomes is why didn't that serve? And if we look at developer tools and we do a refresh and then we get, some of the stuff in here, we can start to look and you can see the type here is all text HTML, text plain, plain, plain. Well, if you serve CSS, JS as text plain, that's not going to work with the browser, right? You got to set the content type and tell the browser, this is the type of content I'm giving you. And then the browser goes, oh, you're giving me JavaScript. Okay, I know how to run JavaScript. Oh, you're giving me, I don't know if CSS will run under that. Probably will, but it doesn't look like it actually. So anyhow, that's that stuff. And it's also interesting when you do this in developer tools, you could click on them over here, and this is in the network tab. So when you come in here, if you're like, I don't know, where did that go? You go to the network tab, and you often have to hit the refresh, and you click the file, and you can see your response headers, and also the request headers. So here's the request headers, right? And then the response header says content type. And so one of the things we're going to do soon is we're going to use Go to dynamically set content type based upon what kind of file we serve. Anybody have any questions?
Is that where the directory where you start from matters?
Yeah, so let's see that. Thank you very much. Here, if I'm in my print working directory, we'll just confirm that, and then I run it again, and then I come over here and I refresh. It's like, great, that's awesome, it's serving. But then if I do the Control-C and I change into source and then into main and then print working directory and ls, and then I say, hey, go run main.go, awesome, and it's all running, and I come over here and I refresh, and it's like, I can't find it. That was 4 to 6 hours of my life. One night. Why aren't you working? I kid you not. And then I called up Caleb because, like, since we've hired him, he takes my calls. And I'm all, dude, what am I doing wrong? Show me. He's all, you got to serve it from, and he explained the entire thing to me. I'm like, ah. So, change directory. And so that's the next thing we're going to do, set content type. And if you're thinking, wow, there's a lot of files to go through there and we're only through 6, I'll take you through buffering, which is 8, because that's really cool. Oh, no, I'm going to take you through 9, built-in file server and buffering, because that's really cool to see. And then you guys will do a show of hands, like how many people are done. It'll probably be the done point. And you could go through the rest on your own and then hire me at my consulting rate of $225 an hour to help you. I'm just kidding. First call is always free. First 5 minutes are free. All right, so where am I? I'm at set content type. Let me just make sure. And I should be on 06, and everything should reset. Okay, so here you can see I'm setting content type. So before we even jump into the rest of the stuff, which is pretty similar, I create a variable content type string, and I'm just declaring it. No assignment there. And then, I'm going to use content type to assign what kind of content type for this one file. I'm looping through all the files that I might find on the server. For whatever file I find, it's going to set the correct content type, because it's going to say, hey, and strings is a package in Go, and one of the methods has suffix. And so basically, hey, does this string, the path, right, end have the suffix CSS? If so, set the content type text CSS. Does it end in HTML? If so, set the content type text HTML. You don't need me to tell you the rest of the story. And then, default content type is just text plain. And so let's look at all that code. And, here's the main. Whoa. And by the way, this is super awesome about WebStorm and JetBrains. Let's say I'm like, oh, what does the handle do? I hold down Command on the Mac. I don't know what it is on Windows. You should switch from that type of a machine anyhow. I hold down Command and I go over something and it becomes a link, and then I could click it and boom, I'm in the documentation in the code for Go instantly. And I could read, I don't know, which one did I click? Handle. I could read right here, handle, right? Handle registers the handler for a given pattern, default serve mux, document, blah, 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 right? And I could read that. Or I could say, hey, what's listen and serve do? Boom, and I'm right there. I'm looking at listen and serve, and this is the Go documentation. This isn't anything I wrote. And so it's like quick access to the raw code of Go and the documentation, so it's super cool. All right, so, basically same stuff, new handler, and so there's my struct, and then, making it a handler by attaching that method to it, and then I get the path, and then print, just logging it out to the terminal for my own interest, and then I read it, IO utility, like, okay, read whatever is at the, /forward from the /forward, and then take that path, and that is, let's see, path right there. So path is what I call right there. But then take the file that I read, the data, and I'm going to add to the header the content type. So we saw that there's the header and the body. I'm going to add to the header the content type. So that's that variable I chose right there, and then write the data, from whatever file I opened, if it's available, if that file got read, and I always like to change these because when I'm working on different versions and files, if I have the same phrase, I sometimes wonder, am I still serving the old page or the new page? So I always change something just a little bit as I change code just to make sure I'm serving the new page. Because one time I started a server and then forgot it was running at one location, because you could actually launch servers from in here, right? And then I started another server from the command line, and it was running the server that got launched in here, and I couldn't figure out, I don't know, so that's why I changed these. So let's run it. Bump, 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 bump. So now all my HTML, CSS, JavaScript, and everything is working. If I go into Developer Tools and take a look at it, you can see all of my content types were well set. How awesome, huh? So, convention? No way. Configuration, conflagration, constipation, consternation, configuration, all the way.
Todd, the reason that Go is so much faster is because in the prior paradigm we had a software that was running the server state, and then we had another scripting language. But this is like all together. I mean, is that part of the reason this is so fast?
I don't. One of the reasons it's fast is it's compiled and not interpreted. And the reason you could work with it, so there's a few things that they had to do with the language to make a compiled language really fast for development. So you don't have to be like, okay, let's see how it's running, and we'll come back in a half hour, right? And go away and have coffee while it compiles. Like it compiles faster than some interpreted languages, whatever take to do their thing. So it's a compiled language, so everything goes down to zeros and ones. And if you look at what happened at Facebook, right? They built it in PHP, which I refer to as piled high poop, and they were having performance problems, and so they created hip hop PHP, and you can read about this or watch videos about it, hip hop PHP. But they basically took PHP and they found a way to compile it as well as they could down to binary zeros and ones, so that it's not running on top of something, on top of something, on top of something. Right? It's not. There's no virtual machine. It's like when you create something in Go, it goes to zeros and ones and it executes. That's it, right? And so I think that's one of the reasons it's super fast. And then there's a few things that in other languages you could do that in Go you can't, or App Engine too. So Google really focuses upon performance. And if you look at web, performance is key to success. You shave off milliseconds, and like, hey, we shaved off 175 milliseconds. And our purchase through rate, the buy through rate went up 12%. It's like, wow, are people that sensitive? 175 milliseconds, right? But there's studies out there that totally support that. So Google's real performance oriented, and one of the other things they do is like when you use NoSQL on their data store, schemaless data storage, right? There's certain queries you can't do because they're just too big of a performance hit. Right? And so you just have to really be aware of that and build your application appropriately. What's up?
It's almost too bad what Google does, because he teaches us that it should be so fast that if it's not instant, I also feel that it's slow. Sorry, what I wanted to tell is it was telling when you showed the settings of Go, then you could see that it uses GCC compile. And it uses CLang, which is a compiler which compiles the Go code to C, and then it uses GCC to compile the C code. CLang is very popular. Yeah, it basically translates the Go code to C, and then says GCC that compiles. I don't know Go, but I can.
No, yeah. That's right.
That's what it does, and CLang is very popular. Probably what Google does is to make sure that CLang compilation phase to C is very efficient. At least the C code, what it generates, is very good.
Yeah,
and GCC takes it over.
But they're currently rewriting that so that, because originally they wrote it that way, but they're rewriting it so that I don't know what the hell, the compiler is Go, no longer GCC, but it's the compiler's Go.
How they can even do it better.
So, all right, so let's see what's next on the docket. Any more questions? We are on 6, so cool. We get to see the buffering stuff. Get add all. Yes, I did mean all with 2. Thank you for reminding me. Get commit. It's my favorite commit right now. Buffering, that's it. Yay. So this is one of the things which is really cool about WebStorm. But I need a large text file here to show this part to you. And there's some instructions right there. And I don't have access to the internet, even if I did. I think it would take us about 8 days at the current bandwidth speed that was here before things started to download it. But I can right click here and I could go to local history and I could say, hey, show history for this folder inside WebStorm. And then inside WebStorm, it has local history. And I could look here and I could see external change, large deleting. So I deleted something. And what did I delete? Movie, MP4. So I'm just going to revert that and close it. And now I have that movie back. But I didn't want that movie in there when I was committing and pushing to GitHub because I don't want to stick 60 megabytes up onto GitHub. So let's look at the code. And I have a large file here. And I've added, hey, when MP4, we're going to serve a video. And then let's just see if anything else here is different. So show hands. How many people think that hasn't changed? Raise your hand if you think this has not changed right here. This chunk of code right there has not changed.
The nil is there, so you don't use any mux.
Yeah, just default serve mux. So that's the same. And then what about this code? Is this changed other than this?
No.
Yeah, so we just added one more content type to our list here. And then what about this stuff here? Any change here?
I don't know if it changed me amigo or not, but
I don't know what a calibre is. I should probably use words I understand. What is a calibre?
How dare you?
Somebody give me a word. There we go.
More.
Me and more, I like that.
There we go.
Me and more. Is it with an E?
No. it's
Okay.
not.
There we go. All right, so now we're ready to run it. And we're running. And just looking at my file structure over here, what am I going to have to type in to get my movie to serve?
Video.
What's my path going to be after my localhost 8080 /
slash video slash movie MP4.
Okay. Let's see. Yeah, I think but these are the questions I've actually asked myself and not answered correctly many times. Like, God, what is my path? So it's kind of a fun question. So let's just check this and make sure it's serving. So that's serving, and templates home HTML was templates home HTML. So I think I'm public video in movie MP4. But you'll see that this starts to change a little bit sometimes depending upon how you write your application. So public video movie MP4. And before I public video, all right, there we go. All right, so we're not going to watch this movie. That's not the point. But I do want to bring up, well, here, just so when you're at home, you can launch your activity monitor and take a look at it. And so let me do that. And I'm looking for main, and so I'm sorted alphabetically, and there's main. And main is 1.2 megabytes, okay? And that's without any buffering, 1.2 megabytes. So that's cool. We served a video. Let's close our server, and then let's do our git add GTI. I'm going to start a competing GitHub and call it GTI. I'm always like, really? Did I switch to branch? Okay. All right, so now we're at a different one. And yes, we switched. And so same thing, but now I have to go back in here to local history and show history. And oh, dang, I got to go back and delete that video. Otherwise, it's going to want to put it up. So deleted, that's probably my video. There it is. And revert. And then main, it's all the same. Oh, no, it's not, because we added buffering. And so we added this new package, buff.io, and you want to read about it, you could click on it right there. And then buff.io, I said, hey, create a new reader, and into that I'm going to pass F. What is F? F is operating system open my path, right? So instead of reading it, reading the file, I'm now opening the file, and I'm passing that open file to my bufferer, and creating a new reader to read that file now. So it's the buffer that's reading the file. And I'm calling that buffered reader. And then where do I use buffered reader? Right down here, buffered reader, write to my output back to the client, right? So my response. And the rest of that's pretty much the same. So all we did was implement the buffered reader. And let's run it and check it out. And I'm just going to hit refresh on this page. So same thing, nothing happened. But check out Activity Monitor. If we go to main now, wow, we went from 1.2 to 1.1. So that didn't quite work out the way I was hoping. I wonder why that, huh?
Proof that you can play it.
Oh,
We don't have to watch it all. I want to see it serving.
apparently not.
Okay. Looks like I'm just trolling.
Anyhow, when I was doing this at home, which, right, always happens, I had my, wonder if I'm doing something wrong. All right, let's try the next one and see what happens. Public video MP4, built-in, I don't know. When I did it at home, it brings it down to like 2 kilobytes, brought it down to, huh?
Alright, maybe it's just the browser.
Yeah, it's Chrome. No, I don't know why that's happening. All right, well, I'm not going to try to troubleshoot it in front of you. Final thing I will show you tonight, unless you guys want to keep going. Let me delete that file out, this one. All right. I had to stop and think about that. It's getting late. How's that? So everything that we've looked at so far is kind of like, let me show you how this works in the background and how you can customize it and build it up from the ground. Or you could just do this. And so this is basically an anonymous, function method right there. That's the handler, the HP file server, HP dir, right? So I'm serving any files at directory starting at the root on port 8080. And so let's take a look. At my root, I didn't specify anything. I could drill in. So it has even more functionality. It's setting all of my content types. Go to my...
Only if you needed to do something specific to change those default behaviors, if you wouldn't use that. Like if you want to do something custom there.
Well, yeah, you want to make it as complex as possible so that you have job security.
No, I'm just trying to imagine the use case for why not go to here, or is it just really just for, reasons of demonstrating what you can do, showing you that within one line, really, here's what's going on.
Yeah, I should probably show you guys some templating. Templating's awesome. Thank you, Rio. So I just, notice this, I just put that file back, movie MP4, but if I go here and I hit refresh, it's not, oh, hey, it does show up. And so now let's look at it and let's see what happens. I don't know what's up with that. But let's look at this. So it went from, what was it before? I thought it was more than that. Yeah. I thought it was 100 or 60 or I don't know. Anyhow. What do my notes say?
Is your video
Yeah.
1.1 megabytes. Yeah, I don't know. I never even tried playing the video, so I don't know why that's not playing. Things to learn. Hey, that's the cutting edge, the bleeding edge. That's the fun. You got to get in and start tearing things up. Templating. You guys want to see just a moment of templating? Yeah, because that's a big part of it. Cool. And git branch. Huh? Oh, thank you. You are hired. Get branch. Let me see a show of hands. Like, how many people are enjoying this? How many people think, wow, this looks interesting and exciting. I think I'd like to try to build something with it. All right, cool.
I'm on
That's
the
cool.
fence on that one.
Yeah.
But,
It takes some work,
actually, I have
man.
a question.
Yeah.
So I don't know Node.js. I've not had the opportunity to work with it yet. Is there any reason to go into Node.js, or would it be wiser just to invest my time in learning Go?
So that's a great question, and many factors come into answering that, right? A lot of people are job oriented, and so there's much more demand right now for Python, Node, Ruby, even PHP jobs, right? Obviously, right? There's a ton of PHP code out there. So what do you want? You know, like what are you going for? For me, I really like the philosophy Bill Gates has, which is that he says, you know, if you want to be successful in life, get in front of what's coming and let it hit you. And just take a minute to reflect on that. Get in front of what's coming and let it hit you. So there's a gamble in that because you have to guess what's coming, right? And so it was a gamble. Like, okay, I'm going to learn Go. Like a sure thing would be Ruby, Python, Node. Like there's a lot of interest, work, code, books, right? But to jump on the Go bandwagon, that's a gamble. And all of the metrics, like if you look at like what is it, RedMonk, or if you look at commits on GitHub, or if you look at questions on Stack Overflow, like they measure that, like what's a language's popularity, and Go keeps rising through the ranks and gaining more and more popularity. But the best solution has not always been the winning solution, right? Take for instance Windows versus Mac, right?
Keep going that way,
right? Mac is a much better OS, you know, Unix based, and Windows is dumb, you know, DOS, right? And Windows dominated, was the winning solution, even though it was the inferior product. And Bill Gates, another quote from Bill Gates is, you know, to Steve Jobs is, you don't get it. It's not about having the best product, right? It's something along those lines, but.
I disagree. To be honest with
Yeah,
you.
Mike
I
was
think,
telling-
you know, originally.
Oh, about
What-
Windows versus OS
what-
10?
doing?
Well, let's not go down that road.
One of the things that Microsoft did was they made it easy for developers. Mac development, early Mac development,
Oh, yeah.
it sucked.
Yeah.
I mean, it was unbelievable. The tools never worked.
Well, yeah, Visual Studio is awesome.
Well, I mean,
I'm
not
a
even
big
Visual
Visual
Studio.
Studio
I
fan.
mean, even going back to early Windows development, the tools actually, the compilers worked, things worked, and they didn't cost very much.
Mhm.
And so it was easy to develop for Windows. And
Yeah.
I think, and Microsoft
That's true.
was
There's
really good to develop.
a lot of good about Microsoft. You're right.
Yeah, and I think, you know.
I need to spend some time on my
Macintosh is a
gaming
religion,
PC.
just like the other. But,
So should you learn Go? I don't know. I mean, how much you want to gamble, right? And also, what's it for? Are you just going to build something for yourself? And if you're going to build something for yourself, I think hell yeah. You know, it's like twice as fast as Node and way faster than Python and many times faster than Ruby. You know, and so you know, yeah.
Hey, could you like throw out any popular apps, web apps with Node that's built in Go right now, or is it still not?
Yeah.
Probably Gmail, right?
Well, you could actually Google that, and I don't have Google right now, but there are some good examples of big companies. And when I asked Caleb about this, I'm like, dude, am I making the right choice? Because I was already in a couple of months on the semester, and we're hiring him to come in and train people. I'm like, what do you think, man? Is Go a good choice? And he said people go to Go when what they're working with, Python, Ruby, PHP, what's the one I'm leaving out, Node. They go to Go when those things stop working, right? And he explained some technicalities to me about where those things hit walls that Go doesn't hit. And so you see really large enterprises, particularly serving files, looking at Go. And one of the things I was going to demonstrate there, for whatever reason it didn't work, it worked yesterday, but was, you know, how you go from this heavy, I'm serving a file, I put the file in memory, which is a huge server load on the server, right? And then I serve it to you, to just being able to bypass that and just pass it straight to the client. And it kept it very light, very fast. And you never took that file and put it into memory. And a lot of those other frameworks, from my understanding, do that. And then, okay, great, we need to have this massive server with tons of memory to work. And so I believe that Dropbox has started doing Go. And then there's also, what is Bauer? Bauer is also doing Go. They started switching stuff to Go. I don't know. So those are some of the two that come to mind that I've read about. But Google it, who uses Go.
So is it easy to go out to some corporate data store with Go?
What do you mean by corporate data store?
Well, like Oracle or Microsoft SQL.
Yeah, totally. Yeah.
And then basically generate an API.
Yeah, I don't know if I'd use the word easy. I mean, it depends upon your level of experience, right? Like that would probably take me a while, but yeah, it has all that built in. It doesn't have database drivers built in, but it has the tools you need to build your drivers, and people have built drivers. And you could say, okay, let me go get this guy's driver, and so for the most popular solutions, yeah, totally, there's drivers that are out there. But again, you're more on the niche road. There aren't 8 books talking about, integrating Go with SQL Server. So let's take a look at templating. So here's the first take on templating. And I bring in text template and net HTTP, and then my main function, pretty much same thing we've seen before. And I'm creating my own handler func. This could be called anything. And my header, I'm adding to it that this is this content type. And then a template. Templates are all about you create a new template, and then you parse it, and then you let me see if I have the notes down here. Create a new template, parse it, and execute it. So those are like the 3 steps of templates. And so I'm creating a new template. This could be any name. And then I'm parsing into it this constant string doc. So later I'll grab that from a file, but right now I just put it right there. And then I'm assigning it to temple. If error is equal to nil, so there's no error, I'm going to execute the template. So new template, parse into it some string, and then execute it. And I'm going to write it back to my response. And nil means I'm not passing in any data. So that's what nil means there. And so when I want to pass in data, I could pass in data right there. And so there's my first template. That's it. And there's no code injection occurring. So I'm not putting anything into it yet. And let's watch it run. And so I'm just looking to see any URL. And so this is kind of interesting. It's running, and I'm going to stay at this URL and hit enter. But that still serves to Hello Jamaica, because the closest match for all that is this. All right, so I can put anything here. And still Hello Jamaica. So you can read about that. All right, so that's template, and Control C, and oops, I got to do my git add dash all git commit dash m. Oh, YouTube runs Go. That's what is YouTube again?
Is Gmail on it, I'm wondering? No?
All right, so but that makes sense then about the entire thing, that I was connecting with Caleb and serving large files. All right, so dynamic template. Now we're going to have some data come in, and let's take a look at main.go. And we have same stuff there, and content type, any name for template, parse, execute. And now I'm passing in some data. Right, so there's some data, and I'm putting the data right here. So this is kind of like, the way that you say, well, that's your injection point, and the period basically means all of the data. So no matter what I passed in, it'd be all the data. And they have some terminology to refer to it. They call it pipelines. So the period is called a pipeline in GoDocs, the path the template will take through the data to get to the data that needs to be injected. The period says, use all the data. And so we could try these different URLs and see what happens. So I've suggested a couple of things we could try to make it work. Let's run it. And let's go with my trials, because I'm sure I put them in here so I won't have to think. So hello, right? And just the /, because if we look at this, what data am I passing in? I'm passing in the request, the URL, the path. So anything after the domain, just the path, right? And all that's been passed in there so far is, you know, bam. So now I got that back, right? Because that's there. See the connection?
This is probably a little bit of a stupid question because
Stupid is good. I was actually going to suggest that as one of the rules for GDG. Be kind to each other, and ask stupid questions, because I often feel like I'm just like the densest tool in the shed. I'm like, I don't get it. What's happening? What's up?
Does Go support? I don't even know if this is in the scope of Go. I'm trying to still wrap my head around like what Go is used for in a broad sense. Does it support like two-way data binding and stuff like that for the templates, for templating?
What's two-way data binding?
Like Angular, basically, that you can have a model, and you can actually bind the model via the template.
They are different animals.
They're different what?
Animals.
That's why I thought it was a stupid question. So like Go is just like completely not in that scope then, because I saw that right there and I'm thinking like, oh, I wonder if data binding is supported.
Is Go always stateless?
So first thing I think of from this conversation is I think about so you're asking me like kind of it makes me think of frameworks like MVC. I don't know if this is kind of what you're getting towards, but but you could set because data and what belongs to what domain and you could, and that's part of what this training on Pluralsight. I don't know if I still have it up. I don't. That training on Pluralsight that I showed you, he goes through how to build an MVC framework with Go, and that's even some of the branches that we have here. You can see I'm starting to get into building some MVC stuff.
Okay.
And so, but it's like
So
there's no hand holding with Go.
Okay, so you're building your own data.
Yeah,
binding
it's
if
like
okay.
here are the tools. Like the analogy might be like I'm going to build a house, and so you go to Home Depot and you order like pre-built frames, right? And here's your gable frame, and you put that on top of your wall frame, right? And with Go, you go to, I don't know, you go. Here's a saw. There are trees. Go to work. You cut them down. You cut your 2x4s. And you build your own walls. And
Okay.
configuration. So yeah, build your own MVC.
Okay, I did figure my question was out of scope.
And then the other one was what was you asking?
Stateless.
Stateless. So the web is inherently stateless. However, with sockets, you could open things and keep them open. The server has some settings, that you could adjust. It's recommended to go with the stateless environment, but I mean, if you need to open something and keep it open and you know how to do it, go for it.
Can we try a hack?
Yeah.
Just leave it running and into the URL, just write an opening script tag, alert, like hey.
Yeah, we're going to get to that. So injection. So that's right here. So right here, 16 injection. I already have that all set up, so I don't have to do anything, and it will totally go through. So we could do that. We could do that right now if you want.
Yeah.
So right now I switched the server to be this. How's that going to be different? Anybody just think about it in your own head. What's going to happen? Yeah, the / goes away. So here I hit refresh and this / goes away. I sliced it off. And then this is what Shaba wants to see. Right, something like that.
Close tag.
Oh, thank you.
See if you can inject, break the system.
So, yeah, but Google Chrome does a lot of stuff too,
Try it in IE.
Old IE. All right, but we'll see some of that in a second. All right, so that's the first injection point, and there's some really cool things. This is getting tiresome right there. You might think, you're really fast typing that. Oh, I typed it a lot. All right, you switched, yes. So this one, I've just switched things around a little bit because there's some stuff down below, and I just wanted to focus on some stuff. So I created a struct here, and I'm storing data, right? So no methods, just data. First name and message. And then here, I'm going to, when I so I create my new template, and then I parse it, and then when I execute it, I'm passing in the context. And the context is an instance of context right here, Todd, more go please. And that's going to fire at this path right here, /Todd. We'll call the Todd func, right? And so, okay, cool, pretty straightforward. Let's run it. So /Todd, nothing here. Oh, wow, you want another beer, James? Yeah. They're right over there. Help yourself. Todd. So what does that tell you, just what you've learned so far, when this brings up James? That means that James is set to just serve at the /, right? Anything, he catches everything. And so there's Todd. And I'll show you this code. Here's Rio. And I thought Ming was going to be here. Ming says, I drank the Google Aid. I don't know if you could see that, Rio. And here's Ming. This is one of my favorite Ming sayings over at Fresno State. I am a problem solver, not a problem maker. Awesome. It's a good saying. All right, so the code for that is, I also put in a / for Ming, a / for Rio, and a /, with nothing on it for James, and then said, different functions to call. And I put those functions down here. And they're all the same, except for I changed the context out, which I created, And so, we're just sticking into those places, first name and message. And if I put in just, just the whole pipeline, we've learned that the whole pipeline is all of the data. So there's the whole data structure. Take that out. Okay, Control C, git add all, git commit -m and git checkout 13 template conditionals, git branch. Make sure I spelled that right. So you could also do conditional logic with your templates. Like, where is everything? And so here's an example of conditional. If equal .url no beer. And they called this Polish syntax. I don't know why. I don't think that's very kind. I guess I shouldn't have repeated that. But stuck in my head. And so basically, your operator is here, and then your operands follow. And so it's comparing the quality, and you could have multiple ones. And if they're all equal, great. So if whatever variable URL is equal to no beer, we're out of beer. Otherwise, yes, grab another beer, first name. So let's look at our struct, and here's URL. So that's what I'm referring to there. It's not like part of the request. And first name message. And so then we have a new template, and we parse into it this constant doc string, and then we create a new context, and Todd, and we assign to those variables, and the request URL path actually becomes the URL. That's just where it got stored. And so if my URL is / no beer, it'll say one thing. Otherwise, it'll say yes, grab another beer in the name. And here's all the data, the period. So let's run that and refresh. And it's Ming, right? So so Ming would come to, this catches anything. So it doesn't matter what is after that /, this will catch it. And then when it does that, it says, hey, is the variable request URL path, which gets stored in this, right, for that context, is that URL, the request URL path, equal to / no beer? And if it's not, then it says, yes, grab another beer, first name. And that's what we got, yes, grab another beer, Todd. And you're wondering why Todd, because Todd is just hard-coded in right there. So now if I have no beer, we're out of beer, sorry. We're not, by the way. There's a lot. Go get some. There's actually one of my favorite commands, go get beer. Sorry, I'm not connected to the internet. It's a joke. Because go get is like, I find that beer helps with Go programming, any programming. I have a friend who is a pretty good programmer in PGP, and he has a friend of a friend story, who always programs stoned. Like he's no good when he's not stoned.
You can accomplish some pretty good things.
But you know, he gets super focused when he's high and just like codes for hours. All right, let's move on. And
Are you sure it's not crystal now?
oh,
You don't get it that done on
I thought I just did that. Yeah, there's a lot of stuff coming online.
I've heard that the parallelism is one strong side of Go.
What?
Parallel distributed stuff.
Yes, it's great for that. Ria, will you come up here and say that into the microphone? Those things that you just said, all those things that are built in Go. Square. Square is built in Go. Tumblr. MongoDB. What else? CouchDB. SoundCloud. YouTube.
There's a whole list. I was sitting here looking at them, just pulling out the ones that I think we would kind of know.
Yeah. So it's definitely getting a lot more popularity, and large companies are adopting it. And that's where I think, you know, if you get in and you understand it, there's opportunity for some good work.
Shopify.
And also to build Shopify.
Shopify.
See, it's just awesome. Like that wasn't the case in January. Those companies weren't advertising they were built in Go. They were building in Go, but they weren't advertising they were built in Go. So here's some conditional logic with templates. We just did conditional. What am we doing? I'm doing loops, right? So now every person, you know, could also have a list of their favorite beers. So in this struct, I am storing a variable beers, and it's a slice of strings. So slice is a wrapper around an array. It's like a dynamic array. It can hold as many as you want. It's actually a little bit more involved than that, but that's my take on it and the simple take on it. And so then I'm going to just loop over a range of beers, right? So however many beers the person likes, it'll print them all out. And so that's basically what that does, and puts it into an unordered list, bullet points. There we go. We're out of beer, Todd. Sorry. Yes, grab another beer, and it printed out my favorite beers. I'll let you Google them. Costco has Le Fin du Monde. I really highly recommend it. If you haven't tried it,
Sounds fancy.
it's way awesome. It means
You're a craft beer drinker?
the end of the world. I'm a crap beer drinker, yes.
You go down you ever been to Pendragon? Down there?
No,
Oh, that's a pretty good place.
that's in Visalia.
No, it's actually over on News and Willow.
News and Willow.
Uh,
I don't know. I barely have, like, last time I watched, this is how I go to the movies. My wife and I had a son 20 months ago, and like that's like I'll go to the trailers now when I have 10 minutes. Otherwise, I'm coding and family. That's it, and work.
I can see the thumbnails of the trailer.
You get to watch the thumbnails. That's it. Google movie thumbnails. That's cool. Get ad dash all. There was he wanted. I have a hard time with your name. I'm sorry, Chaba. Chaba wanted to see code injection, so we'll stop with that. Get branch. Get checkout. We got two more. So this is, you could put templates in templates. Hopefully I typed that right. My eyes are getting blurry. And yes, And so here, and we haven't quite got to the point yet where we are grabbing files. I think this is the one where we do, is it? No. Anyhow, I've got two templates. I got a head and I've got a foot. And then I'm including the footer right here. And I'm including the head right here, right? And then I'm passing into the header file the data title, which is right here, right? And so when that comes in, then inside header, that becomes the new pipeline, and I just referred to it like that. So that's kind of the way they work. I hope that made sense. Otherwise, you could run this at home and meditate on it, and it'll make sense. Anyhow, let me switch now to anybody dying to see that one run?
No.
All right, you'll have to run it on your own. Sorry, one hand quickly pulled down. All right. So here's a injection. And so I've got a couple of strings here. More beer, please, sir. And then I have, this one without the script tags and this one with the script tags. Can you guys see those? Let me take them off so they're a little bit more clear. Right? So we'll just go through and try each of these. And where are those strings getting put in? So parsing my doc and then executing, and here's the message, the data that gets passed in. So that's where it gets passed in. And it gets put here between a paragraph tag, in which case this one will execute, and it gets put here in between a script tag, in which case this one will execute. And you'll notice that this is also up here. And so text template doesn't do any type of escaping, but if you use a wrapper of text template, HTML template, which has all the functionality of text template, plus a brand new kitchen, it does do all the escaping. And by brand new kitchen, I mean it's got additional stuff it does. I was trying to be funny. And thank you, Rio. And let's run it. And so I'm just looking here to see it's just serving on root. And so let's hit refresh. And more beer, please, sir. That was right here, correct? So let's take that off and then restart the server. Control C, by the way, is how I'm doing that for those who are watching this and don't know. And then restart it, and boom, I just got whatever owned. Does that make you happy? It's kind of cool, right?
I'm an ethical hacker, so...
You're an unethical hacker? That's so cool that you're just open with that. I really appreciate that.
It doesn't make you happy.
More unethical hackers need to sort of come out of the closet and own who they are.
It's interesting.
So there's that. Let's try this one.
Can you change the text just a little so we would see the difference?
Oh, yeah, sure, I could change the text a little. I like that. I gotta restart the server. For those of you in the back row, biatch. And so now let's just change it from text HTML or text template to HTML template. And I saw something go orange, but it's fixed. So it's all escaped. If you look at page source.
It escapes.
And they have an entire thing about, it's actually context aware. So if it's in CSS or JS or HTML or anchor tags or whatever, it escapes it appropriately for the situation. So yeah, man, I like hacking too. Let's get together and break some stuff. Last thing, it seemed like there's one more thing I wanted to point out. When you're working with WebStorm, because that was a big part, like getting your thing running, you'll have to come into preferences, and once you've got Go going as one of your plugins, come down here to the Go thing where you have languages and frameworks, and then this will have to be set, and you just basically click those periods and it knows where to go on my computer. I don't know how it'll work on yours. But you set that to your Go root, and then even though it says path here, this goes to your Go root. It's the SDK, which is, wherever your SDK is located. And then your libraries, you'll have to set a couple of these things to libraries. Like a lot of these will get picked up, but for my code to work, I actually had to set one all the way down to kind of the root of my, anyhow, you can play with that, and that will clear up some of your code syntax. Because before that was there, some of my code wasn't registering as like, what? I don't know where to find that function. Is registering as unknown. So that was something I had to set. I hope that this has been really valuable. Just a little bit of a summary. That's my main intent. Don't clap yet. But my main intent is to take away a lot of the bleeding I did when trying to learn this, and to teach you what are some of the big pitfalls that I fell into. So the main thing I could say is, man, go to Pluralsight and take the 2 trainings they have there, and that should be your first step. And that's one of the main things. And then making sure you understand workspaces where you have bin package source folders, and your source folder has the github.com, and then the github.com folder has a folder with your username at GitHub in it, and then everything beneath that is all your code. And that's a big thing. And then I really like WebStorm. I've played with WebStorm. I've played with Atom. I've played with Sublime. And out of all of them, WebStorm is my favorite. And you could Google WebStorm Sublime look, and you'll find a thing you can implement to make your WebStorm look like Sublime, which I really like Sublime's look. And then inside WebStorm you import the Go plugin and get the most recent one. So make sure you say Show All. Grab the most recent Go plugin, and then also make sure you're aware of setting the pass or whatever inside Go's preferences. That's a really important thing right there. And then checking out my GitHub account where I've been through those trainings and kind of set up all that code and just following it from there. It's pretty neat. It's pretty powerful. I'm excited because I like building stuff. I love the creativity of it, and I'm not quite there yet, but I'm super close to being able to get things back online and have databases connecting to my websites and create websites where people can use them and do cool stuff. But it's been a hell of an uphill climb. It's been a hell of an uphill climb to learn all this. And hopefully, now that there's a little bit more of a path through the jungle, it's going to make the going easier for everybody else, including you guys. So thanks for letting me share it with you, and I hope it was interesting and beneficial. And if you need any help, just give me a shout out. I brought a couple of business cards. Some of them are my City College cards, and some of them are another card for a company that I'm helping my wife's cousin with. And or just get my email, Todd McLeod. I don't want to say that on YouTube, but Todd.McLeod at FresnoCityCollege.edu. All right, I wish you luck.